Hey, 7th grade. We're going to be starting the new unit. The new unit is about circles and area. Today we're going to be talking about circles and circumference. So, as you can see, I've drawn this wonderful circle here with the aid of a pop can. So, one of the first questions one of the first things that a person noticed, his name was Archimedes, is that every circle, it seemed that as the diameter got bigger, this area across that, the area around the circle, also called the circumference. So pink is diameter, and black is called the circumference. He noticed that as the diameter got bigger, the circumference got bigger, basically at the same scale. So a medium size circle like this diameter across the middle here, and this circumference around this circle seem to be about the same ratio apart. And so for this one, circumference would be the black one, and then the radius would be something like that. Or sorry, the diameter would be something like that. And he wanted to find this ratio, which remember is just one number divided by another number, of the circumference divided by the diameter. He suspected that this ratio of the circumference of a circle divided by the diameter of a circle was always equal to a certain number. And he was right. This number ends up being the number pi. No matter what size circle that you have, the circumference of that circle divided by the diameter of that circle is always going to be 3.1415926 ... So I had a wonderful thing planned where you were going to do stuff on paper and all that stuff, but now we have to do videos. So you'll just have to follow along as best you can. Let's go ahead and talk about some vocabulary. So a circle is all points that are a certain set distance away from a point called the center. So for this circle up here, all the points that are this far away from that center, so let's say this is 1 inch, every point that is an inch away from the center, so if I go in any random direction, if I go this direction, that's 1 inch. If I go this direction, that's 1 inch. If I go this direction, that's 1 inch. This black line, this circle, is every single point that is an inch away from the center. So that's what a circle really is. It's every point that is a certain set distance away from a point called the center. So this point right here is called the center, and that distance is called the radius. The radius is the distance that all points on a circle are from the center. So the radius would be these lavender lines here, these 1 inches. The radius for this circle up here is 1 inch, assuming that that is 1 inch. That was just a guess on my part. The diameter is the distance from one side of the circle to the other side if you pass through the center. So in this case up here, if I take any single point on this circle, let's say this point right up here, the diameter of this circle is the distance from this point to the other side of the circle if I pass through the center. So getting a straight edge, I get that the going through there, right, like that. The distance from this point to this point is the diameter. Now, if you think about it, if I go only from the center to that point, that's a radius. And if I go from this center to that point, that's also a radius. So the diameter is actually also equal to 2 times the radius. Okay. So the diameter is equal to 2 times the radius. Or the radius is half the diameter. Okay. Let's go to our first example. Example 1. I have a circle here, and the diameter, that's all the points, or sorry, the distance here, the diameter is equal to 14 inches. What is the radius? The radius is lavender. Well, I know that the radius is equal to the diameter divided by 2. So if the diameter is 14, then the radius would be 14 divided by 2, or 7 inches. So to go from here to here, that distance is 7 inches. And to go from here to here, that's also 7 inches. And the whole diameter itself is 14 inches. Okay, that's A. B, I have a circle, and the radius is 5 centimeters. What would the diameter be? Well, if the radius, and I should have drawn this in lavender, is 5 centimeters, then the diameter is equal to twice the radius, or 2 times 5, which is 10 centimeters. Not too bad. Not too bad. I want you to try the on your owns on the bottom of 318. I want you to do number 1 and number 2. So pause this video, do these 2 numbers. It says that the diameter is 16. What would the radius be? And for this one, the radius is 9. What would the diameter be? So figure these out and resume the video when you got that. All right. Diameter is 16. The radius is half of that, so that would be 8. Sorry, and these are in centimeters, and these ones are in yards. The radius here is 9. The diameter would be twice that, so it would be 18 yards. All right, moving on. One more circumference. Going to define that. This is the distance around a circle. That is called the circumference. And the circumference and the diameter have a special relationship where pi, it's actually, that's the Greek letter pi, looks like that. That is the ratio of the circumference divided by the diameter, which is approximately 3.14. We will use either 3.14 or the calculator. The calculator of pi, which is 3.141592654, blah, 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 blah. So when I'm writing things down, I'm going to write 3.14 simply because I don't want to have to write all of this. When I'm on the calculator, I'll probably write pi simply because I have that button available to me. We should almost never get answers that are significantly different. There'll always be within, hundredths of a value from each other. So like if I use this value, I might get the answer of like 62.43, whereas if we use 3.14, the value would be 62.42 or 41, or they're different, but obviously they're just the same thing. We just use different values for pi. So the circumference of a circle is equal to pi times the diameter. Or if I wanted to rewrite the diameter as radius, the circumference would equal pi times 2r, two times r. And just a mathematical thing, we typically write the numbers first. So it would be 2 pi times r. So that's one that you should know, and that's one that you should know. The little stars there, you will need to know that. Okay. One of the things that I like to do is I like to play disc golf. Oh, I had a... Oh, well. I like to play disc golf. The disc, this is example 2, by the way, has a radius. So this is the disc. Has a radius of 5 inches. What is the distance around this circle? Right here. Well, I know the radius is 5 inches. So I'm going to use the formula here that deals with radius. So the circumference is going to equal 2 times pi times r, which is 2 times 3.14 times r, which is 5. And when we do this, we get 2 times pi times 5. We'll get the answer of 31.4 inches. That's the distance around this Frisbee disc. 31.4 inches. Okay. And that's A. For B, has a watch face. So we got the circle there, and we got the I don't know, getting my artistic skills going. There we go. This is a watch face. 12, 6, 3, 9. The diameter going all the way across the center is 28 millimeters, or a million miles. What is the circumference? Well, we know the circumference is equal to pi times the diameter. So the circumference is going to equal 3.14 times the diameter, which is 28. And we get 28 times pi, 87.9. Okay, so it actually worked just to do 88 millimeters. I did 88 because the 6 would make the 9 go up, which carries over, so it would be 88 millimeters. So the circumference around this watch is 88 millimeters. So if you are a glass maker, you know that in order to fit a watch that's distance across is 28 millimeters, you would need an 88 millimeter cutout of glass. Okay, on your own. Numbers 3, 4, and 5. You're going to need to find the circumference. Find C. So we've got a car wash token whose radius is 2 centimeters. We've got a swimming pool whose diameter is 14 feet. And then we have a dinner plate whose diameter is 9 inches. Find the circumference of each of these 3 things. All right, pause your video, and do these on your own, please. Okay. The answer for number 3 is 12.56 centimeters. This one would be about 44 feet. And this one here would be about 28.26 inches. So this swimming pool one, people would obviously advertise it as a 14-foot swimming pool, right? However, that doesn't help the people who make the rubber to go around it, right? The rubber to go around the swimming pool is more important to them, and they know that they have to make a rubber tube, a wall basically, that is 44 feet long in order to make a swimming pool that's 14 feet wide. So that's the relationship between the diameter and circumference, and why these things are important. One of the many, many, many reasons. Okay. We're going to skip example 3, which is estimating the diameter, and move straight on to example 4. Well, you know what? Let's do example 3. It's not too bad. Okay. So there's caution tape. Caution. Okay. And it says that the circumference decreases 10.5 inches. the circumference decreases 10.5 inches. So the distance around this caution tape thing has decreased 10.5 inches. What is the best estimate for the diameter of the roll after the decrease? Well, oh, sorry. The initial size was, the circumference was 31.4 inches. After it decreases 10.5, the new circumference would be 31.4 minus 10.5. That would be 20.9. So if I know that my circumference is 20.9, my circumference is going to equal, it says it's asking for the diameter. This question is asking for the diameter. A is 5 inches. By the way, you should be following along in your books. I can't spend all the time writing out each of these problems when it's already written out in your books. So make sure that you have your books next to you so that I can just say, look at example 3 and you can see what it's doing. This is 12 inches. Okay, these are the diameters. I know that the circumference is equal to pi times the diameter. Well, I know the circumference is. Circumference is 20.9. I know what pi is, that's 3.14. I need to know what the diameter is. So what I'm going to do is I'm going to divide 20.9 by 3.14. Divided by 3.14, that will be my diameter. Well, this is pretty close to, well, let's just get the answer. 20.9 divided by 3.14. 6.6. Okay, looking at these, it looks like B is the closest answer. All right, example 4, semicircle. A semicircle is half of a circle. 1/2 of a circle. If I have a full circle, then I have a circumference. But if I wanted to find what half of a circle would be, like let's say I wanted to find the perimeter of this shape, assuming that this is a perfect circle, which I know it's not, but whatever. I know that the distance across here is 6 meters. Well, I want to split this up into two different distances, because there's no way that I can find the distance of a curved thing and a straight thing in one calculation. What I can do is I can find the circumference of half of a circle. So if I make this my lavender color, this is half of a circle. And my pink color is just going to be this distance that is 6 meters. That's just given to us. Well, then the only thing that I really have to worry about is that I want to find what half of the circumference is. I know that the circumference is equal to pi times the diameter. So if I want to know what half the circumference is, it's going to be pi times the diameter over 2. And this is actually a formula that you should know. This is the perimeter of a semicircle, at least this part right here. It does not include the top part. So my lavender part is going to equal 3.14 times the diameter of 6, but then I have to divide that all by 2. So I do this, pi times 6, and then I divide that by 2. I get an answer of 9.4, basically. Well, 9.4. So this curved part here is about 9.4 meters long. But when I add this top part that is 6 meters long, the perimeter of the entire shape would be about 15.4 meters. If you need to rewatch this example, do it, because it's not that bad, but it looks a little complicated. Or you can just try these on your own. Try on your own 7, 8, and 9. Now 9 is tricky. It is a semicircle. It has this part, but it only tells you that the distance from here to here is 15 inches. So you would have to find the whole diameter, or you can use the equation of a circumference using radius, because this is the radius that they give you, not the diameter. The other ones were nice and gave you the full diameter. Okay, go ahead and find the perimeters of each of these three shapes. Pause the video now and do that. Okay. Here, curved part. I'll go ahead and do the curved parts for you. Curved parts is going to be 3.14 plus the flat part, which is 2, gives you 5.14 feet. Here, the curved part is right around 11. When you add that to 7, you'll get 18 centimeters. And finally, this one here, this one's the tricky part, the tricky one. The curved area of this is right around 37.1. Sorry, 47.1. But when you add the entire distance, that's 15 and 15, that's plus 30, that would equal 77.1 inches. Okay. Assuming you're able to do all that, the answer, or the questions I want you to do are on page 321 through 322, and I want you to do numbers 3 through 12. Number 12 is actually a real life thing. Look around something in your house, look around something in your yard or something that you would want to know the circumference of and why, and then find it. Okay. I want you to do number 14 and numbers, well, I guess 14 through 16. Okay. I'll finish that by tomorrow night. Have a good day.